Hello there. We're still working on coin change. This is the bottom up approach that you should be I promised. So here we go. So this is the DFS method, top down, and as you could have seen earlier, that we printed starting from the last item from 0 up until the current amount. So we're gonna replicate this code bottom up now, and so we're gonna set the DP equals the amount plus 1 times the amount. Oh, where's my face? Sorry about that. My bad. So this is the amount plus 1. So this creates this DP, so 0, 1, 2, all the way up until the amount. And with that, we can start filling in OK. So what we filled up earlier was, so it takes 0 to get to 0 amount, and takes 1 to get to 1 amount, and 2 to get to 2 amount, and so on and so forth. So let's set that. So let's set the 0 to be 0 again. And now let's set up the for A. We're gonna do for every amount from a 0 up until the amount, which we did earlier, in range of 1 through amount plus 1. So we get up to the amount, we don't get amount plus 1. So then we do a for C in coin. So we take each coin, which we've done earlier as well, for each coin. And according to this code here, what we've done is that we're going to take the minimum for that amount, so if a amount minus C is greater than or equal to 0, we're going to set that particular amount to be equal to the minimum of the amount, DP of the amount minus the cost plus 1. Or we're going to take DP of the amount. So basically, this is the minimum. Basically, what happens is that every time we take a coin, we set that particular how much it will cost for that coin, and we're taking the minimum to get to, let's say, 1, or get to 2, or get to 3, just like here. So then with that, we are going to get all the way up until the amount, and that means we can return. So return DP amount if DP amount has changed, which is going to be less than, if it's less than the amount plus 1, because it cannot be anything more than the amount plus 1. Well, you know why? Because, well, that means it's more than the number of coins available. So with that, we can return our code and get our answer. So yes, we have a success. So this is the bottom-up approach. It is significantly, well, slightly faster sometimes and sometimes slower, but that is the bottom-up approach. It's basically a translation of the top-down method. As you can see, if you print out the DP, it looks exactly the same. So let me just print that out. Print DP of A. So run code. Whoops, that was not what I meant. I meant to print the whole DP. My bad. As you can see, everything was at 12, and we started setting each item to, as particular spot to be the amount necessary to get to that specific place. It is exactly the same as the DFS method that I've showed earlier. Let's print that out as well. So let's run the code and compare. Oh, whoops. So DP was not instantiated. Let's instantiate that. So DP equals. Let's see, what sort of DP are we doing? We're doing, I believe that it was infinite math dot inf. So let's say float math.inf. So math.inf times amount plus 1. Oh, whoops. Was that the code before? I'm not sure. Let's see. I believe that we did something else, but will this work? No, it wouldn't. Right. So what we did earlier was a dictionary, empty dictionary. Still wrong. I wonder what's going on. We did not run. Wait, we did run it. What? Let's see. Let's see. Let's see what's wrong. I'm not sure what is wrong here. But I don't think I've done anything different. No. Let me check. The 0, 0, right. Okay. Right, we did not instantiate the 0th item. So, right, so as you can see here, the numbers are pretty much similar, the same. I'm thinking, so this code was very difficult to read the second time go around. Why was it very difficult to read? Let's see. This space here did not encourage me to read it. So if it's less than 0, return math infinite. Does it tell me why that's the case? Else if return the number, or else return this number here, the remainder. Okay, so I think that this we can do better. So here's what we're gonna do. We're gonna separate this piece of code from here so that it makes it easier for us to read. So we're gonna run if statements. So they're more like guardlet statements. So and we're gonna do rem equals 0, return 0 instead of putting this information here, because this is just more logical. And we're gonna run 3 if statements instead, and then we're gonna run this code. I think that would help readability in on our end, and that way it's better code. Of course, this is gonna slow it down the code by a lot. Let me just submit it again. So whoops. So right, let me explain what we have done, the improvements that we have made. So improvements is that this way we ignore this piece of code here by setting this. We'll read it there's time, and hopefully it will remember next time. So make it easier to read. The reason why it was difficult to read was because we did not want to read all those statements, and we wanted to get this done quickly. And so that's why we ended up with the error that we had. So this way, we just read this line of code. We're going to take the minimum of DFS plus 1 for coin in coins, for C in coins. So we're going to go all the way down to the 1 and 0, and take the minimum, and then take 1, and take 2, and take 3, all the way up until 11. And so with that, we're going to get our number, and what happens when we hit the base case. When we hit the base case, it's either 0, then we return 0. If we've found it, we've seen it before, then we return that number. And if it's less than 0, we're going to set it to math infinite. So basically, the minimum is non-existent. And with that, we return the remainder amount, which is the amount that we put in at first. And that's how we're going to get our answer. And so with that review, I think it has helped me write better code when you can't read it quickly. And, you know, I really wanted to read it as quickly as possible for you. And that's why I ended up in that state, which is good. In the sense that I saw that how poorly written my code was, and how much better it can be. Also, in terms of readability, what we've done here is basically less readable than that, this right here. So how can we make this more readable? I think when we come back to this tomorrow, I will see how unreadable this is and fix the readability of it. Because this is direct translation of this right here, about these statements. And so, right. Let me see something though. So I think this being a direct translation, this is gonna be bad, because this is amount plus 1. Oops. I think we can do better by setting this as a max number. Let's run the code again, and let's submit, and this way we can do better. Or we can also find out why it doesn't work. Also, why this method doesn't work in this direction, why it needs to be in math infinite. So let's look into that problem as well, since we're here. So earlier we set it at math infinite, and that worked. But this time we set it at the amount plus 1, and it did not. So why is that? Let's see. So we're taking the minimum between all these numbers, and I guess it was greater than amount. The amount plus 1 was less than some other amount, and that's why it did not succeed. Let's run it like this. I bet it will work. And it does. And let's submit. Okay, it doesn't work again. Why? I think it's because of the amounts. So why was it set to be a dictionary? Is because, well, I see that the DP of this number probably doesn't. Okay, let's run the code. Okay, looking pretty weird. So we got all the way up to 100 here, but apparently by setting this to 100. It did not work. So what's the reason? Let's run it. Oh, so let's run it and find out what's going on here. I mean, it's basically the same stuff, right? Okay, so because of the infinite number of items that we are using, integer output limit existed. So that means basically like we just overflowed everything. Yeah, I mean it works for 11. So yeah. So that's why it works for the dictionary works better in this case because of I think overflow. So that's why we use a dictionary for our DP here in this sense. Okay, we've learned a lot today about our previous solution and our current solution, and looking at our code about like how we are moving down. Maybe we should write some comments about the code. So we will do bottom up, starting with the smallest amount and building up to the amount desired. Yeah, I think that's right. And here we will do top down. Starting with the amount and asking the smallest amount to build up to the amount desired. Yeah, okay. Hopefully these comments will help next time I do this problem. When I read it, because we will be coming back to do this in terms of the DFS. And so we will be coming back for this problem one more time for the BFS method. So yeah, that's it for today. And yeah, we'll talk more about this stuff tomorrow. I thank you very much for watching this video. If you enjoyed the video, please like and subscribe. If you want more videos, check the link in the description below. Let me know if you want short videos, long videos, and videos where I mess up lots, or I'm exploring, or just, you know, solving the problem as fast as possible. So thank you very much, and I'll see you in the next one.